back. Today we're going to talk about special parallelograms. In the activity you did a little bit of an exploration about two different shapes, which I didn't give you the names of, but I asked you to look at some specific characteristics of them in order to try to figure out some of the properties of these shapes. When we look at these two shapes, basically I'm going to call them shape 2 and shape 3, and on the outset I told you to try to name them. The first one wasn't too bad, shape number 2, because you looked at it and you probably thought to yourself, that's a rectangle. And when we go through the properties of a rectangle, being in this column that's shape number 2, you're going to notice that the interior vertex angles were all 90 degrees. The nature of a rectangle is to have all 90-degree angles at the corners. That's why it's called a rectangle. Rect meaning right, angle obviously angle, so right angle shape. The diagonals, they were bisected, but the way that they were bisected looked like they were congruent, and those measurements told us that they were congruent. The angles formed by the diagonals, they didn't bisect, but they were complementary. So as those angles went to the corner, they made 90 degrees, which makes sense because a right angle has 90 degrees at the corners. And the sides, we know from a rectangle that opposites were congruent. Shape number 3. Maybe you didn't know what shape number 3 was. Maybe you tried to call it a diamond, but its technical name would actually be a rhombus. And each of the interior vertex angles were bisected by the diagonals. And the diagonals were bisected, but they were also unlike the rectangle in that they were not congruent. So one was shorter than the other, though they were still bisected. The angles formed by the diagonals, they bisected the corners, and all the sides were congruent. So unlike a rectangle that had the 90-degree angles but different sides, this one didn't have 90-degree angles, but it had congruent sides. The general properties then of a rectangle are going to be outlined by these theorems. First of all, I want to label a couple things on this rectangle, knowing that it's a rectangle, meaning right angle. We're going to see that a rectangle has all 90 degrees at the corners. Okay, so it's also coming out of this fact that it has these parallel sides here and parallel sides here. These are special parallelograms because they're always going to be parallelograms, but they're going to have these special traits. Some of the theorems that we have down here outline these things. 641. If a quadrilateral is a rectangle, then it's a parallelogram. Well, we see that if we draw a rectangle in here, we're going to quickly find out that these 90-degree angles at each corner follow the same rules that we know for parallelograms. Consecutive angles are supplementary. Also, each consecutive angle has all of them supplementary. Opposite sides are going to be congruent and parallel. And so my conclusion is going to be that this is a parallelogram with one 90-degree angle. And that's going to mean that each of the subsequent angles is 90 degrees. The other conclusion that we can make about rectangles is that this theorem says we have diagonals that are congruent. I'm going to try my best. Not too bad. And these diagonals are going to be congruent. And so if I label this A, B, C, D, the conclusion that I can make from this is that AC is congruent to BD. So congruent diagonals. And this is going to be really, really convenient because now they're bisected and they're congruent. So this is good. Let's talk about a rhombus for a minute. Rhombus, like I said, was a shape with 4 congruent sides. And because its 4 sides are congruent, it also falls into the category of parallelogram, and so opposite sides are going to be parallel. If a quadrilateral is a rhombus, then it's a parallelogram. Well, my hypothesis just happens to say that I've got this shape that has these 4 congruent sides. And using, this deduction that we've used before, we know that if these are equal distance apart, then we have to have a shape that has parallel sides. And so if all of these are the same length, which they may not look the same length, but they are, the conclusion is that AD is parallel to BC, and AB is parallel to DC. So therefore, and this is the therefore symbol, it is a parallelogram. Okay, so this shape is a parallelogram. So a rhombus is another type of a parallelogram. If a parallelogram is a rhombus, then its diagonals are perpendicular. We looked at that in the very first exploration of this lesson. And so what's going to happen here, and this is actually kind of a cool feature of a rhombus, is that we're going to have a 90-degree angle here. And because we have a 90-degree angle there, all of these are going to be 90 because they're going to form linear pairs and vertical angles, and so all of these in the middle are going to be 90 degrees. Okay, so that's a really nice feature of a rhombus as well. The last feature of a rhombus is that if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. And so what we get here is diagonals that are going to bisect these angles. Well, that's going to mean that I can mark some things here. These two are going to be congruent. These two are going to be congruent. And of course, we remember that in a parallelogram, which a rhombus is, opposite angles are congruent. So these are all going to be the same now, but these could be different. So I'm going to mark them accordingly. And it's going to look like this. And this is really cool because diagonals in rhombuses have a lot of angle things that happen. 90 degrees where they intersect, bisect the opposite angles. Let's look at something. Example 2. Using properties from rhombuses to find measures. RSTV is a rhombus, find each measure. Well, I'm given these two things. And I remember that because it's a rhombus, that means all sides congruent. And because all sides are congruent, I'm just going to mark them up. And I can come up with this equation. 4x plus 7 equals 9x minus 11. If they're congruent, you can set them congruent. So I'm going to go ahead and add 11 here. And subtract 4x. Do it all in one step. And I'm going to have 18 on this side is equal to, and I'm going to have 5x. So this is going to be x is equal to 3 3/5. Okay, and that's pretty much how that goes. The second example I'd like for you to go ahead and try on your own, and that's going to be something that you can definitely do. So go ahead and try this next one on your own. Let's talk about a square for just a second. Here's what we know about a square, right? From a young age, we've learned that a square has all the sides the same. Perfect. We also know that it has 4 90-degree angles, and so it's kind of having an identity crisis. Because, for one thing, we have 4 90-degree angles. So that tells us it's a rectangle. On the other hand, the second part tells us that it has 4 congruent sides. So that leads us to believe that it should be a rhombus. And so what we have here is an identity crisis. Is it a rectangle or a rhombus? Because it has characteristics of both. Well, what I'm here to tell you is it's actually both. It's actually both a rectangle and a rhombus. It fits into both families. All right, guys, that's all I got for you today. Thanks for watching. We'll see you next time.